Hi guys, so in this video we are going to explore on the concept of position vector. Sometimes in real engineering application, it is necessary to measure like the length or the distance across 2 points in space. Space ni bukanlah maksud space as in angkasa lepas kind of space. It's more like a 3D kind of space. As you can see, the picture over here is actually a figure of Cessna 172 aircraft. So let's say you need to measure the length or the force vector of the wing strut as shown. The line of the wing strut is connecting between 2 points in space. Let's call these 2 points to be point A and point B. Let me just quickly redraw the position of point A and point B in 3D space so that it's easier for you to visualize how the vector looks like. Let's say the point over here is point A and let's say the point over here is point B. So the location of the wing strut vector crosses from point A to point B as shown. So this vector line, which doesn't cross the origin of the 3D space, is known as the position vector. And usually, kita bagi dia symbol R, okay? In order to analyze the position vector, kita boleh utilize the coordinates of these 2 points. So, let's say coordinate A can be represented with AX, AY and AZ. Coordinate kan, so dia ada X, Y, Z nya value. So, accordingly, coordinate B can also be represented with BX, BY and also BZ. If we are to rewrite this coordinate with a Cartesian vector, then the position A would be AXI hat plus AYJ in the direction of Y plus AZ in the direction of K. Okay. Similarly, vector B in the Cartesian vector form can be represented with BXI plus BYJ plus BZK. Okay. The line of the A vector would look like this. It starts from the origin and then it is directed towards the point A. So that is our A vector. Similarly, the B vector, it starts from the origin and then zoop, dia jalan terus pergi ke point B. And this will be our B vector. So if you look at this combination of 3 vectors, it actually looks like a triangle law, kan? So the triangle law involves vector addition. So basically, vector B, which is from the tail to the arrowhead, is equivalent to vector A plus with the position vector, which we call it R. Okay, so if you want to determine what is the R vector, so kita bawa the R vector ni ke kiri. So since we are calculating the position vector between point A and B, we can also rewrite the R vector as RAB as shown. So RAB, kalau kita susun balik this equation, it will become vector B minus vector A. Dalam erti kata lain, the position vector along point A to point B can be calculated by deducting coordinate at point B with coordinate at point A. Okay, now let's say this line represents vector A and the magnitude of vector A is 5. So we can actually divide this vector line into 5 equal distance. So this would be region 1, region 2, region 3, region 4 and region 5. So if I were to draw a vector line with the same direction with vector A at only one region, so this blue line is known as the unit vector, and usually we represent the unit vector with symbol U. The unit vector can be calculated by dividing vector A with magnitude A. So, if we calculate the magnitude of unit vector, we will get a value of 1. So, that is unit vector. It is a line vector when the magnitude of the vector equals to 1. Takkan lebih, takkan kurang, takkan jadi tempat perpuluhan. It will be exactly 1. if we are to rearrange the unit vector in Cartesian form, whereby in IJK format, so the unit vector is equivalent to AX divided with magnitude A in the direction of I plus magnitude of AY divided with A in the direction of J plus AZ divided with A in the direction of K. So the magnitude of the component in I direction or in X direction is equals to cos alpha, while the magnitude of the vector along the J direction is equals to cos beta, and accordingly the magnitude along the Z direction will be equivalent to cos gamma. So you can use this relationship to determine what is the direction of the unit vector. Let's look at this example. In this example, given a rubber band, a getah kan, is attached between point A and point B. So the question asks you to find the length of the rubber band, or in other words, you need to find the R between point A and B. And the second question asks you to find what is the direction of the rubber band. So kalau kita tengok, this is a 3D kind of problem. So they wanted to know what is the alpha, beta, gamma angle of the rubber band. So in the first step, let us find the coordinate of both points, which is point A and point B. Okay, for point A, along the X direction, the distance is positive 1. So coordinate here is 1. And then along the Y direction, it's like exactly dekat tengah-tengah at 0 kan. So it will be 0. The coordinate at Y direction is 0. And the coordinate at the Z direction is 3 meter. But you notice the punya direction is downward. So the value is negative 3. So the coordinate of point A is 1, 0 and negative 3. So if we rewrite this in Cartesian vector format, so we can write the position of point A, RA, to be 1I plus 0J minus 3K. Okay, accordingly, you can also find the coordinate of point B. Okay, along the X direction, the distance is 2. Tapi notice the direction is toward the negative side of X. So it will be negative 2. And then along the Y direction, it will be positive 2. And along the Z direction, it will be positive 3. So the coordinate of point B will be negative 2, 2, and 3. If we are to convert this coordinate into an equivalent Cartesian form, then the position of point B or RB would be negative 2I plus with 2J plus with 3K. Quite straightforward kan? So, if you want to calculate what is the position vector of the elastic rubber band from point A to point B, or RAB, then we have to use the subtraction formula, whereby position of B or RB minus with position of A or RA. Okay, so we rewrite the position vector of B, which is negative 2I plus 2J plus 3K, minus with position vector of A, which is 1I plus 0J minus 3K. Let us solve it accordingly to each direction. Okay, first we look at the I direction, negative 2 minus 1I, and then along the J direction is 2 plus 0, and then along the K direction it will be 3 minus minus 3, or 3 minus negative 3K. Okay, we just solve this simple mathematical operation. So it become negative 3I plus 2J plus 6K. So this is the position vector of the elastic rubber band from point A to point B. Okay, this is the position vector of the elastic rubber band from point A to point B. What is the unit of this position vector? So kalau tengok dalam our figure, so all the measurement used are in meter. So the position vector is actually in meter. So right now, we are interested to know what is the length of the rubber band. Okay, using this position vector, we can calculate the magnitude of the rubber band from point A to point B. Using the magnitude from each component in the position vector, the magnitude can be calculated whereby negative 3 kuasa 2 plus with 2 kuasa 2 plus with 6 kuasa 2, and then you square root all to summation, and you will get the magnitude of the elastic rubber band to be 7 meter. Okay, first question done. Now, to solve for the second question, they ask you to find the direction of alpha, beta, gamma angle. So, we can find the alpha, beta, gamma angle by utilizing or changing this vector equation into an equivalent unit vector. Okay? If you can recall from the previous slide, we can calculate the unit vector by dividing the vector expression with the magnitude of the vector. So in this case, we can divide the position vector with the magnitude of the position vector. Okay, this would be our position vector and this would be the magnitude of the position vector. So we put that in our equation to determine the unit vector. Okay, notice the vector equation at I component is -3. So, kita letak sini and then we have to divide with the magnitude of the position vector which is 7. So, this is the value in the direction of I. And then, for the J direction, the magnitude is 2. And then you divide with the magnitude of the position vector which is 7. And along the K direction, the magnitude is 6. And then you have to divide it with the magnitude of the position vector which is 7. So, this would be the equation for the unit vector. The magnitude of the I direction would be equivalent to cos alpha, whereas the magnitude at the J direction would be equivalent to cos beta, and the magnitude at the K direction would be equivalent to cos gamma. So we can use this trigonometric relationship to determine our alpha, beta and also gamma angle. Okay, quite straightforward. Cos alpha sama dengan -3/7. So, you rearrange the equation, then you can calculate the angle of alpha, which is 115 degrees. Using the same calculation in the second expression, which is cos beta equivalent to 2/7. So, you can simply calculate the beta angle to be 73.4 degrees. Okay, simply repeat the same procedure to calculate for the gamma angle and you will get the gamma angle to be 31 degrees. Okay? If I were to redraw the vector of our elastic rubber band, then it would look something like this. This angle would be our alpha angle, this side would be our beta angle, and this one would be our gamma angle. If you notice in the previous video series, the part 2 one, we focus more on the force vector. So we calculate what is the magnitude of the force and the direction of the force between 2 points in space. It's actually very similar. But in this video lecture or in this video series, you will notice that we actually focus on the position vector. So position vector is different with force vector. Kalau force vector tu you calculate everything in Newton, for example. But in position vector, you are interested with the length of the physical object. So it is being used to locate a point in space relative to another point. Although the force vector and the position vector are two different measurement. Okay, ingat, force you kira daya, whereas position you kira the length or the distance. So although the force vector and the position vector are two different quantity which give different magnitude, but then we can relate these two parameter using the unit vector. So the unit vector for force vector is equivalent to the unit vector for the position vector, the R. Okay, so if you remember, unit vector ni magnitude dia mesti wajib dan sepatutnya equates to 1. It will not be more than 1, it will not be less than 1, it would not be titik perpuluhan, it will be equal to 1. So we can relate the force vector with the position vector using the unit vector. So if we rearrange this equation, then we can express the force vector to be equivalent to magnitude of force multiplied with the unit vector. So kita katalah kalau kita tak tahu what is the unit vector, but we know the position vector, so we can multiply the magnitude of the force with the unit vector using the position vector punya expression. Now, Let us strengthen our understanding on the force vector with this example. Okay, in this example, nampak tak ada lelaki kecil di situ is pulling the cord with a force of 350 Newton. So the magnitude of the force is given. So the question asks you to express the force acting on the support A as a Cartesian vector. So nampak je perkataan Cartesian vector, terus fikir dalam kepala otak, the form must be in IJK punya format. And then, do they want the position vector? No, they want the force vector. Okay, the second question asks you to determine its direction. So nampak je direction, nampak je is a 3D kind of case. So terus ingat, you kena calculate the direction as in the alpha, beta, gamma punya angle. So let's try to do this. Okay, so kita tahu the magnitude of the pulling force by our little man here is 350 Newton. So it will look something like this. So the question asks you to find what is the force vector in Cartesian form and also what is the direction of the vector. As for the first step, let us find the position of coordinate A. So coordinate A along x direction is 0, and then along y direction are also 0, but at the z direction is 7.5 meter. So the direction is upward, so it's a positive value. So if we rewrite this position vector in a vector form, so our position vector A or RA would be equivalent to 0i plus 0j plus 7.5k. Okay, now let us find the coordinate of point B pula. So along the x direction, the distance is 3 meter from origin. So it will be 3 positive, and then along the y direction is 2 meter. Tapi it is directed towards the negative side, kan? So the coordinate becomes negative 2, and the coordinate along the z direction would be 1.5 meter. Okay. Accordingly, we can rewrite the coordinate of point B in Cartesian form, as in 3i minus 2j plus 1.5k. Okay, now that we know the position A and also the position B, we can calculate the position of vector AB pula. Macam mana nak kira? Position vector of AB or RAB is equivalent to position of B minus with position of A. So, position vector B sama dengan 3i minus 2j plus 1.5k minus with position vector A, which is 7.5k je lah. Yang I and j tu is 0. So, kita boleh just neglect in our equation. Okay, we can solve this equation and we'll get a corresponding value of 3i minus 2j minus 6k. What is the unit of this position vector? Tengok, measurement is all in meter. So, position vector is also in meter. Next step, jom kita kira the magnitude of the position vector, ataupun dalam erti kata lain, kita nak kira the length of the tali from point A to point B. Workspace tak muat, saya tu lihat belah sini lah pula. So the magnitude of position vector or the length of AB can simply be calculated by using the magnitudes of the position vector, whereby magnitude of RAB is equivalent to 3 squared plus negative 2 squared plus negative 6 squared, and then square root all the summation value. You'll get a corresponding length of 7 meter. Okay, if you recall from the previous slide, we can relate the force vector with the position vector using the unit vector punya formula, whereby unit vector is equivalent to force vector divided with the magnitude of the force, and this is also equivalent to the position vector divided with the magnitude of the position vector. So kalau kita rearrange the equation, then our force vector can be calculated by multiplying the magnitude of the force F with the unit vector. So unit vector kita tahu kita boleh juga kira dengan menggunakan nisbah position vector, whereby kita substitute the unit vector with position vector divided with the magnitude of the position. Lah ni, magnitude of the position vector kita dah tahu, which is a pulling force by our little man over there, which is 350 Newton. So you just letak 350 Newton dekat situ. And then what is our position vector? Position vector tadi kan yang hang pada kira yang ni, 3i minus 2j minus 6k. Magnitude of the position vector pun kita dah tahu, which is this 7 meter. So, kita substitute this value into our unit vector punya equation, whereby magnitude along the I component is 3 and then magnitude of the position vector is 7. So, 3/7 in the direction of I minus along the direction of J, magnitude dia 2 and then you divide with 7. So, that is the value at J, and at the K direction is -6 divide with the magnitude of R, which is 7 meter. Okay? You multiply the magnitude dalam kurungan tu dengan 350 Newton and you will get a corresponding vector of 150I minus 100J minus 300K. Okay, so that is the force vector in Cartesian form. So you have answered the first part of this question. Okay, now kita nak solve the second part of the question, whereby we want to know what is the alpha, beta and gamma angle of our force vector. Okay, if you recall, this value over here yang saya bulat dengan warna biru ni is actually the ratio of the position vector with the magnitude, kan? And that value is actually the unit vector. Okay, let me rewrite it over here. And if you recall, each component of the unit vector represents the cos angle of the respective direction. For example, the component along the I direction ataupun along the x-axis is actually equivalent to cos alpha. The magnitude of the component in the j direction is equivalent to cos beta. And the magnitude along the k direction is equivalent to cos gamma. So, sama macam the previous example I gave to you, you can simply calculate the alpha, beta, gamma punya angle using this relationship. Okay, why don't you try this on your own? And this is the alpha, beta, gamma answer that you should get. Okay, kalau ada apa-apa soalan, ada any confusion, please feel free to contact me. I do not bite. Don't worry. Okay, that is all for now. I hope you understand the concept of force vector in the context of three-dimensional view. Remember, use your right hand coordinate, x, y, z. This is your 3D axis. Pusing-pusing lah macam mana. This is your positive x, y, z axis. Okay, so in the next series, we are going to look into the concept of equilibrium, particle equilibrium. Okay, so try to do the e-attendance exercise and try to do the tutorial. In the next session, we are going to discuss more details on the tutorial solution. Okay, till then, bye-bye.